Alright, today we are interested in finding volumes of solids of revolutions. What that means is we want to take a region, and what we've done the past few days is we've taken a region and then we've stuck slices on top of it. This time we want to take the region and we want to rotate it around the x-axis or the y-axis. So what I have here is, this is the graph of 1 minus x squared. I want to take this region right here, and then I want to spin it around the x-axis. When I take it and spin it, that gives me a three-dimensional figure that I want to find the volume of. Okay? So here's what it looks like when you spin it. Okay, so there it is. We're on a three-dimensional space. There's the 1 minus x squared, and then if I take it and spin it, I think this is the right one. Yep. If I take it and I spin it around the x-axis, you see that it turns into a three-dimensional figure. So if I kind of turn it around, you kind of get a look at what this thing looks like. Okay, so I took that region and I spun it around and it turned into this three-dimensional figure. So we are interested in finding the volume of three-dimensional figures like this that are taken from a region and spun around the x-axis or spun around the y-axis. Okay? And it is going to be very similar to what we did with the slices. So remind me, what do we do with the slices to find volume?
Find the area.
Area for the slices, then find
What the S would be. Or what
find the variable, plug the variable into my area formula, and then do what to my area formula? Integrate it. We're going to do the same thing today with this. So what is it I need to know about my figure to be able to find the volume of it? What the area is of one of my slices. So we need to know, if I slice this thing, what does that figure look like? What do you think it'll look like if I take a slice of this?
Circle.
It's going to look like a circle. So let me show you how this turns into a circle. Take a little bit off from the right. Take some off from the left, and then I spin it, and you'll see that a slice of this thing, when I rotate it, a slice of this thing is a circle. So there's the side view. You see that the slice of this thing is a circle. Okay? So I know my area formula is going to be
Pi r squared.
pi r squared is going to be my area formula. So what's the next thing I need to figure out? What r is. Okay? So if this is my circle, what's r going to be? Isn't it going to be from here to the x-axis? Isn't that what it's going to be? So the question is, what is this point out here? What's going to represent that? Okay? So let me expand it back out so you can look at it, and then we will figure out what the r needs to be. Okay, whoops, went the wrong way with one of them. And if we go back to the original picture, I'm taking this thing and I am rotating it around the x-axis. So what is my radius going to be? It's just going to be the top minus the bottom, just like we did with the slices. So my radius is going to be top minus bottom. So in this case, what's the top?
Y.
The equation, which is 1 minus x squared, and what's the bottom? 0. So it's going to be 1 minus x squared minus 0, which is just 1 minus x squared. Okay? So let me go to a blank page. So we had y equals 1 minus x squared. Our area formula is pi r squared. We figured out our r is 1 minus x squared. So that means my area formula is pi times 1 minus x squared squared. now we're ready to integrate. Where are we gonna integrate from on this one?
-1 to 1.
Yeah, it's gonna be -1 to 1. Now, can I integrate the outside on that thing? No, why not? What's the derivative of the inside? -2x, I don't have an x, so that means I can't integrate the outside. So what do I have to do to it instead? Multiply it out, good. Alright, so it's going to be x minus 2 over 3x cubed plus x to the 5th over 5 from -1 to 1. Which one gets plugged in first? 1, so that's going to be 1 minus 2/3 plus 1/5. Plug in the -1, that's -1 plus 2/3 minus 1/5. So 1 and 1 give me 2, -2/3 and -2/3 gives me -4/3. 1/5 and a positive 1/5 gives me 2/5. What's my common denominator? 15. So I'm going to have 30, 20, and 6. So that's 10 plus 6, which gives me 16 pi over 15. What does 16 pi over 15 represent? The volume of that three-dimensional figure we get when we take that region and rotate it around the x-axis. So anytime I find volume, whether or not it's slices or whether or not it's revolutions, what do I need to find first? The area, and then I need to find the variable. I plug the variable in and I integrate. That gives me volume every time. Okay, let's try those. But anytime I'm doing revolutions, what is my area formula going to be? Pi r squared. Because my slice, anytime I'm doing revolution, my slice is always going to be a circle. Okay, next one. So I have y equals the square root of x minus 1, x equals 10, and y equals 0. That is what creates my region that I want to revolve around the x-axis. So we probably need to see what that looks like. Anytime they give me information like that, what do I want you to do first? Graph, what part of that do I want you to do first, though? Yeah, I want you to do these two first. So y equals 0 is going to be the x-axis, x equals 10 is going to be out there. What do you know about the square root of x minus 1?
Half a parabola.
Half a parabola. Okay, so I know it's half a parabola, so I need to, it's probably going to stop at 10, obviously, so I need to know where it starts. Where does the square root of x minus 1 start?
1.
It's got to start at 1. Why can it not start at 0?
That is negative.
Yeah, because I put 0 in there, it gives me a negative. So it's always going to start where whatever x value makes it 0. Okay, so then we know it's half of a parabola from there. So now I'm ready to go. If I'm going to find volume, what's the first thing we start with?
Area.
Area. What's my area formula going to be on this one?
Pi squared.
Okay, please write down the area. Whenever you're doing any type of volume formula, please write down the area formula. Okay, it takes some of the confusion away. Then I also want you to tell me what the variable equals. So in my case, what's r going to be? Square root of x minus 1. Top minus bottom. Top is square root of x minus 1. Bottom is 0. Okay, I plug in. So it's going to be pi times x minus 1 is my area formula that I want to integrate. pi outside, x minus 1 on the inside. We're going to integrate from where to where on this one? 1 to 10. So that's x squared over 2 minus x 1 to 10. Plug in 10, that's 100, divided by 2 is 50. Plug in 10 is going to give me 10. Plug in 1 is going to give me 1/2. Plug in 1 is going to give me 1. So 50 minus 10 is 40. That 1 is going to turn positive, which makes it 41. And then I have 41 minus 1/2, which gives me 40 and 1/2 pi, or what is that as an improper fraction? 81 over 2 pi, or 81 pi over 2. And what does that represent? The volume of that figure rotated around the x-axis. What's something that would look like if I took that and rotated around the x-axis?
Kind of like a cone without a top, sort of.
I would say it looks like a bullet. If I take that and rotate it around, it looked like a bullet.
That works too.
Okay. All right, 2 more. So those 3 equations will trap the region we want, and we want to take that region and we want to rotate it around the x-axis. So y equals square root of x, y equals 6 minus x, y equals 0. So what part of that do I want to start out and graph first? So y equals 0, which is the x-axis. Okay, what about the square root of x?
Half the parabola.
At parabola, where does it start? 0. If I go to 1, what would my y value be? 1. What's the next x value I want to plug in?
4.
4, because that would give me 2. And my next x value? 9. So 5, 6, 7, 8, 9, and that would give me 3. So I got half a parabola. It looks like that. What about 6 minus x? What do you know about that?
It's going to be a straight line.
Straight line. Crosses the y-axis at 6. So there's 3, 4, 5, and 6. Slope is -1. So down 1 over 1, down 1 over 1, down 1 over 1. So it looks like that, which means my region is going to be this area right there. I'm going to take that region and then rotate it around the x-axis. So if we're going to find volume, we start with area. Since I'm rotating, my area formula is pi r squared. Now I need to find my r. What's different about this one?
You've got 2 instead of.
I've got 2 different things that make up the top, right? From 0 to 4, what's on top? Radical x. And then from 4 to 6, the 6 minus x is on top. So I'm going to have to make 2 integrals. Very good. I'm going to have 2 different r's. What's the first r going to be? Radical x. What's the second r going to be? 6 minus x. So plug the first one in, that gives me pi x. The second one is going to be pi 6 minus x squared. So we integrate the first one, put the pi outside, put the x inside. Where does that one need to be integrated from? 0 to 4, because that's where it's on top, is from 0 to 4. The second one needs to be integrated from 4 to 6. Because that's where that one's on top, is from 4 to 6. So pi, that's x squared over 2 from 0 to 4. The second one is pi. Can I integrate the outside on that one?
Yes.
Yes, because
The derivative is -1.
the derivative of the inside is just -1. We can handle that. So if I integrate the outside on that one, it gives me that. But the derivative of the inside is -1, so I need to make sure I put a negative in front. So now we plug in. First one, I plug in 4, that's 16 over 2, which is 8. What happens when I plug in 0? It's 0. I move on to the next one. I plug in 6. What happens when I plug in 6?
0.
I get 0. And actually, I'm going to go ahead and move this negative to the front of pi. Put it out there, so I get 0. And then minus, when I plug in 4, 6 minus 4 is 2, and 2 cubed is 8. So that looks like we end up with 8 pi plus 8 pi over 3. And if we get a common denominator and add them together, we end up with 32 pi over 3. What does 32 pi over 3 represent? The volume of this three-dimensional figure that I get when I take this and rotate it around the x-axis. Everybody okay so far? All right, last one. This one, our region is closed in by x equals -y squared plus 4y, y equals 1, x equals 0. And this time, instead of spinning around the x-axis, we want to take this and we want to spin it around the y-axis. So, let's see what this region looks like. I need to graph y equals 1 and x equals 0, which is right there, and I think I need to graph it. I think there's something missing. We'll find out here in a second. No, I don't think there is. All right, so -y squared plus 4y. I should want to plug in what? What type of value can I plug in? Y values. Obviously, one of my y values needs to be 1. So if I plug in 1, that is -1 plus 4, which is 3. Okay, and let's continue to move up. So I plug in 1, now let's plug in 2. If I plug in 2, that is -4 plus 8, which is 4. So the next one would be 4. Plug in 3. That is -9 plus 12, which is back at 3. Plug in 4. What do I get when I plug in 4? 0. So I now have my region. want to take this and we want to rotate it around the y-axis. If I'm wanting to find volume, what do I need first? Area. Since I'm rotating, my area is pi r squared. Then I need my r. If I'm rotating around the x-axis, how do we find r? Top minus bottom. If I'm rotating around the y-axis, how do I find r?
Right minus left.
Right minus left. So what's on the right side here?
Y squared.
Negative y squared plus 4y. And the left would be 0. I plug in. Which gives me that. Set up the integral. We're going to go from where to where?
1 to 4.
1 to 4. 1 to 4. So it'd be 1 to 4. Can I integrate the outside?
No.
No, so what do I have to do? Foil it. If I FOIL, that gives me y to the 4th minus 8y cubed plus 16y squared. Integrate that. And we're not going to worry about plugging that in because that looks like it'd be pretty nasty to get some numbers. The most important thing is that we can get to that point. That's the calculus. Okay. That and integrating it is the calculus. Everything else is just number crunching. Okay? So, to recap, if I'm going to find volumes of solids of revolution, what do I need first? Area formula, and if I'm rotating something, my area formula is always pi r squared. Then I need my radius. How do we find radius? Top minus bottom if I'm going around the x, and right minus left if I'm going around the y. I plug in, I integrate, I've got my volume. Question on that?